Distribution class surge arresters. As the first line of defense against service loss and equipment damage, they're a necessary part of any utility distribution system. But the potential for violent failure in porcelain-housed arresters can also make them a necessary evil. Ohio Brass has the ideal solution for either new construction or retrofit applications. REA-listed polymer-housed MOV arresters that protect your system and personnel. As the first American manufacturer to produce a polymer-housed distribution arrestor, Ohio Brass holds the lead in this cutting-edge technology. Ongoing research, innovative design, demanding production standards, and exhaustive testing, these are the fundamental reasons that the Ohio Brass Type PDV 65, PDV 100, and PVR polymer-housed surge arresters are better by design. Early research conducted here at the Ohio Brass Research Center in Wadsworth, Ohio, was focused on the development of the optimal surge arrestor varistor. This research resulted in the introduction of our Dynavar zinc oxide varistor, now at the core of our line of polymer-housed MOV surge arresters. Described as the near-perfect arrestor valve material, the Ohio Brass zinc oxide varistor provides low discharge voltages and rapid response. Protective qualities that are simply not provided by silicon carbide arresters. Continuous research and testing of raw and processed materials, housing design, and production processes have resulted in today's highly dependable, stable, and above all, safer distribution surge arrestor. However, because the needs of utility distribution systems are constantly changing, our research and development efforts continue to push the envelope of chemical formulas, processing methods, and arrestor design toward a safer, more reliable, and effective product. Design limitation. With a porcelain-housed arrestor, it's the nature of the beast. Porcelain is a brittle, easily damaged material that can, even under the best conditions, be damaged during shipping and installation. And a damaged housing means that moisture can invade the arrestor and cause it to fail, sometimes violently. Another disadvantage of the porcelain-housed arrestor design is the internal free space that is built into the arrestor. This free space lends itself to the action known as seal pumping. Normal temperature cycling will result in seal pumping, causing internal moisture buildup that will eventually lead to arrestor failure, potentially violent arrestor failure. A housing that is prone to damage and an internal cavity that multiplies the problem of moisture ingress. Together, they account for a reported 86% of all failures in all porcelain-housed arresters. In gapped arresters, an additional 5% of failures are due to external contamination. The Ohio Brass gapless polymer design solves this problem by providing 50% more external creepage distance than normal porcelain designs. These are the fundamental deficiencies that Ohio Brass engineers have designed out of our polymer-housed MOV distribution arresters. No other manufacturer has the experience and expertise Ohio Brass holds in the production of polymer housings. Beginning in 1976 with our polymer highlight insulators, to the introduction of the first American-made polymer-housed distribution arrestor, Ohio Brass has explored, developed, and refined polymer housing technology. Today, our silicon alloy ethylene propylene rubber produces the best all-around polymer housing available. This proprietary silicon alloy ESP compound was found to possess an unrivaled combination of advantages over porcelain, Teflon, polyethylene, butyl, or silicon rubber. Comparative studies have shown these materials to be inferior to the silicon alloy ESP Ohio Brass uses to produce arrestor housings that not only possess greater mechanical strength, but also greater resistance to ozone, UV, electrical tracking, and corona. Additional advantages of our arrestor design include the avoidance of the porcelain arrestor's conventional gasket seal or large springs that only increase internal free gas volume. Equally flawed are arrestor designs that use no springs to maintain electrical contact or fail to use silicon grease to eliminate the problems of RIV and moisture ingress. Gapless metal oxide varistors wrapped in epoxy fiberglass, coated with silicon grease and enclosed in a moisture-tight polymer housing. It is this exclusive Ohio brass design that minimizes free gas volume inside the arrestor and virtually eliminates moisture invasion, seal pumping, and RIV. Still other advantages of the Ohio brass arrestor include the rapid surge response that results from its gapless design, increased fault current withstand, and greater leakage distance in smaller, lighter arrestors. From our silicon alloyed ESP housing and gapless epoxy fiberglass wrapped MOV to recent advances in our mounting hardware, Ohio brass researchers continue to test and develop our product design, making sure we get it right on our drawing board so that you'll never have to go back to yours. We at Ohio Brass know that the high promise of research and design is realized on the production floor. That's why we use a two-plant split function method of production, designed to maximize plant efficiency and staff proficiency. No other manufacturer of polymer-housed MOV arrestors has the experience and proven track record of Ohio Brass. And unlike others, we manufacture our own MOVs and polymer housings. All Ohio Brass varistors are produced and tested by the staff at our Wadsworth, Ohio facility, while our polymer housings are molded and final assembly and testing achieved by the staff at our Aiken, South Carolina plant. Recently completed expansions to both plants have further enhanced our ability to produce and deliver polymer-housed distribution arrestors that will greatly improve your customer service and quality of power. Following completion of the production process, each varistor is stamped with two sets of numbers, a classifying value and batch number. The batch number serves as a sort of fingerprint that allows a varistor to be readily traced back to its raw materials. Every Ohio Brass varistor is subjected to a series of high-energy electrical tests. Discharges in these tests can be as much as 35,000 amps. Following high-energy testing, samples are taken from each production batch for extensive quality assurance testing. Our accelerated aging program and other quality assurance tests greatly exceed actual service requirements and industry standards. If samples fail to meet our established levels of performance, the entire batch is scrapped. Only if the samples meet our own demanding standards is the batch permitted to be shipped to the Aiken plant for final assembly. This is the Ohio Brass Assembly Center in Aiken, South Carolina. Recent upgrades have both refurbished and improved its manufacturing technology. This multi-million-dollar investment represents our commitment to providing the utility industry with high-quality, leading-edge product in quantities that will keep pace with demand. As the first American manufacturer of polymer-housed arrestors, Ohio Brass has developed what our experience tells us is the best all-round housing material available today. We use a proprietary silicon alloy ESP to injection mold polymer housings that offer superior resistance to UV, ozone, chemical, and thermal aging. Our ESP rubber also has superior tear strength compared to plain silicon rubber. Add to these advantages the inherently good electrical characteristics of EP, the increased safety that it provides personnel, its resistance to damage from shipping, installation, and vandals, and it's clear the Ohio Brass silicon alloy ESP housing possesses a wealth of advantages over any alternative housing material. The assembly process next combines polymer housings and their metal oxide varistors. In assembling our MOV modules, Ohio Brass uses small Belleville washers to maintain electrical contact. This is critical to the long life and effectiveness of our arrestors because it eliminates RIV and high current arcing. Another exclusive feature of our arrestors is the layer of silicon grease that surrounds the MOV module within its polymer housing. The silicon grease reduces RIV and acts as an added barrier to moisture ingress. The diameter of the varistors used in producing our arrestors determines their energy handling capabilities and protective characteristics. The 32mm diameter discs contained in the normal duty PDV 65 are rated to withstand 2 discharges of 65,000 amps. The heavy-duty PDV 100 arrestor with its 40mm discs and the PVR with 48mm discs are both rated to withstand 2 discharges of 100,000 amps. The assembly process is completed when the arrestor components are combined into a single moisture-tight unit that is sealed by an end plate and insulated base bracket. Before being fit with external hardware and packaged for shipment, every arrestor is first subjected to a series of electrical tests. At Ohio Brass, testing isn't just a matter of getting the right answers, it's asking the right questions. In addition to our ongoing efforts to strictly monitor and control our raw materials and manufacturing processes, there is a demanding series of routine and quality assurance tests for both our metal oxide varistors and ESP housings. Having already passed a series of electrical tests, each MOV is visually inspected for chipping, pinholes, metallizing, or collar damage. Only then is each distribution varistor subjected to a single 8x20 microsecond high current impulse. Finally, every Ohio Brass varistor is subjected to a classifying discharge of up to 10,000 amps, and the resulting voltages are measured and stamped on the disc to serve as a basic reference value. In addition to these tests, which are performed on a 100% basis, still more tests are performed on a statistical sample taken from each production batch. These tests include a square wave test that establishes the varistor's maximum energy handling capability, a life test to gauge its aging characteristics, a high current test that measures the stability of the varistor's electrical integrity, and an AC test. But this still doesn't complete the testing schedule. Even though industry standards don't require 100% testing of arrestors, Ohio Brass goes above and beyond the standards to ensure the quality and reliability of our finished product. Our tests include a starting voltage test that confirms that the correctly rated module is in the assembled arrestor. This test is vitally important to users because it ensures that the arrestor has been energized at system voltage and will protect their equipment. Finally, an RIV test measures internal ionization levels to be certain that the arrestor will cause no radio or television interference. Because the real test of the Ohio Brass polymer housing is not only how, but how long it will function in the field, all our housing performance tests are designed to simulate the harsh conditions and demands of actual service. Our tracking wheel test, seen here, evaluates the ESP housing's tracking and weathershed erosion resistance. Samples are subjected to a contaminant bath, followed by a prolonged exposure to 40,000 volts, twice the voltage level of actual service. After repeated testing cycles, which to date number in the tens of thousands, none of our test samples have shown any signs of tracking. Through these tests, combined with our ongoing outdoor aging tests, Ohio Brass continues to examine and analyze the performance of the materials and design of our entire line of polymer-housed distribution surge arrestors. Asking the right questions, setting standards far in excess of actual service requirements, getting the right answers. Our aggressive testing is just one more reason that Ohio Brass products are better by design. Our PDV 65, PDV 100, and PVR distribution arrestors provide specific levels of protection for specific system voltages or service conditions, and are outfitted with hardware to exactly meet user specifications. In an effort to help customers better identify their needs, Ohio Brass offers distributors and users this slide rule. It allows you to precisely calculate your needs according to system voltage. Having chosen the basic arrestor, available hardware attachments can be chosen by referring to the guide on the slide rule's reverse side. It's a small item, but at Ohio Brass, it's just one more way of making certain that not only are our arrestors better by design, they're also easier to select and tailor to your application. The PDV 65, PDV 100, and PVR from Ohio Brass. Together, they represent the state-of-the-art from the leader in polymer-housed metal oxide distribution surge arrestors. Better by design.